Welcome to our video on programming theory and specifically our introduction to computer programming in general. If you haven't already downloaded our PowerPoint on programming theory, make sure to go to our website. We have a video on how to access these resources, so click on that video, watch it, get the programming theory PowerPoint, and then resume this video so we're all on the same page. So first off, let's take a quick look at what is computer programming. First is the means of communication with the computer. You're basically giving the computer a laundry list of commands and procedures that it needs to carry out in highly accurate means. And it's very obedient. It needs precise directions though, but it does exactly what you tell it to do. And programming languages serve as a way to make the computer to do something you want. So you create a function or a program to have the computer do a list of steps to essentially as a means to an end for developing a website, for developing a new program, even developing programs like PowerPoint, Microsoft Word, Microsoft PowerPoint, stuff like that. It all requires a lot of computer programming and telling the program and the computer what to do at what time, and if this happens, then what the computer should do. And this all goes into computer programming, and when you become a computer programmer, you have to keep that in mind as you progress through your task of programming to think about what the computer needs to be able to do and what you want the computer to be able to do. So next we have some definitions. First is process, which is a series of actions or steps taken to achieve an end. That's basically computer programming at its most basic level, which is a process, and it's basically they do this first. The computer does A, then B, then C, then D. And that's the same thing as a procedure, which is a series of actions conducted in a certain order. Whatever you put in first, the computer will do first, then it'll move on to the second task. So you have to make sure your order is correct. And an algorithm is an ordered set of steps to solve a problem. And when you look at computer programs, everybody calls them algorithms, algorithm that, algorithm this. That basically means that they're trying to solve a certain problem. For instance, if you develop an algorithm to predict how obesity will rise in the next few decades, that's going to be a computer program that takes in information and is able to predict and solve the problem of predicting what the obesity rates might be like in a few years. So that's just one example of an algorithm. You're going to be developing a few very simple ones as practice as we move on through the other video tutorials. Next we have how do computers work. So they have a level structure from the kernel, the hardware to the kernel to low level, high level, low level programming languages to high level programming languages, and you have the most privileged, which is the kernel, to the least privileged, which is the user interface, which is what we're looking at right now, where you have the X button, you have folders, files, all that stuff that looks pretty but doesn't really give you a lot of access to the computer. And the programming languages are a way to link the user interface to the kernel. It's a kind of an intermediate level where you gain more access. You can do more stuff with your computer than you would normally be able to do with just the friendly, user-friendly interface. Next, we have computer levels. So this is a image I found online. It's pretty useful at visualizing how computers actually work. In the middle, you're going to see the kernel right here I clicked on, and you're going to see that there's a few reams outside. There's a ream 1, ream 2, ream 3. These are drivers, and then applications right here are basically where you would have some of the programming languages. And on the very outside, if you count this black line, that would be your user interface. So it has at least privilege, as you can see right here, but you're trying to use these applications, trying to use these device drivers, these computer programming languages to access the kernel, which is the most privileged right here. So that's basically what you're trying to do. And we have another image right here I got online. It gives you another good idea of the hardware right here. And there's kernel machine language, which are zeros and ones. You've probably seen that a lot. Actually, if you look at our channel banner, you're going to see an example of zeros and ones. It's used in a lot of movies about computer programming. And that's basically machine language. Nobody really programs in that anymore. And we have assembly language and high-level languages. These basically connect what you have when you have other languages, visual languages, your interface back down to the machine language hardware. And we have Fortran, C, and Pascal. These are some very high level programming languages. C is a very important one that's used for a lot of programs like Python that are based on C. And then you have object-oriented programs and visual language. And object-oriented programming is like Python, Java, they will all fall under this category. So they're a bit easier to understand, pretty powerful, but still don't have the most access to the hardware, but they're still much, much better than the user interface at accessing what the actual computer can do and all the capabilities of your computer hardware. So this is just a funny thing I found online, and a lot of people don't understand what program actually does. It's not magic. It's not anything exceptional. It's just a way of telling the computer what to do. You're essentially writing down a recipe for to solve a problem, and that's programming at its core. So machine languages are basically ones and zeros. You turn switches on, you turn switches off. 1 equals on, 0 equals off. And it's a basic language of computers. Down here you have an example of a machine language. You're going to see zeros and ones. That's how the computer interacts, how the computer talks to itself, basically. Intermediate languages. They translate directions to machine languages, and they include most of the common languages: Unix, Linux, Java, Python, C, C++, C++, HTML. So all the languages you're going to be learning about computer programming, they're going to fall under intermediate languages, where you can connect the actual user interface and your directions to the machine language. And because nowadays no one programs in zeros and ones, because that would be extremely inefficient, you're going to have to learn some intermediate languages if you still want to get some stuff done on the computer. Here's a good example, a visual aid to how the computer actually works. Up here you have some of your intermediate languages right here. This looks kind of like something like Java or HTML or Python even, just a program right here. This is actually written in C, as you can see, the C program, but any program up here would work. You put that into the compiler, which will then basically connect that to machine language, translate it into zeros and ones, and the computer does its job. And that's basically, in a nutshell, how computer programming works. And the importance of programming. Now, basically everything you have that you have access to on the internet, on your phone, on applications, apps on your phone, smartphones, all that stuff, it's been programmed through computer programming, so it's extremely important to how the world currently operates, and especially important to the future when we delve into a new era of high technology, high information, high-speed internet, all that kind of stuff. And without computer programming, we wouldn't have the internet, we wouldn't have these applications, including YouTube, including the video you're currently watching, PowerPoint, all that stuff. You wouldn't have it without any computer programming. And lastly, computer programming is really important to careers. I stress this when I teach at workshops, which is that programming careers can fall into a lot of categories. You don't have to study computer science. You can do marketing, you can do economics, but you will always rely on some part of computer programming if you want to further yourself in that job or that career. And in fact, according to the Forbes list of 10 skills that will get you hired, 2 of the most valuable job skills, so basically 20% of the top 10 skills, are actually computer programming and computer applications. So that's extremely important to your career prospects in the future, and it's just a skill that can only help in the future. And that's all we have for this video. Stay tuned for more videos on computer programming tutorials and computer theory. Thank you.